Hello, this is Attila Gabriel Brzezinski of Bluish Green Productions, and today we're here to take a look at the Spryt Animator Pro asset for Unity. This video will serve as a feature overview and an introduction to get you started using the package. Coming from the Asset Store, you should have a similar Import Unity package window. Now, here in Unity 2017, you cannot import the example, only the scripts, which is what we're about to do. In fact, to view the assets that are used in the example, please use Unity version 2019.2. When working in any other version of Unity, you can use the existing scripts that make up the Spryt Animator Pro system, but the example scene will not work. With the example unticked, we can go ahead and import this into our project. And you might see a number of these errors cropping up, and that's because Spryt Animator Pro makes use of some features of the .NET 4.0 language, which are not available in this edition of Unity by default. So to fix that, let's go to Edit, Project Settings, Player, and I'm going to scroll down to where it says Scripting Runtime Version, and I'm going to switch this over to 4.6 Equivalent. And then I'll have to restart Unity, so let's go ahead and do that. Okay, and now you can see those compile errors have disappeared. In later editions of Unity, you can go into your project settings, select Player, and then scroll down until you see the API compatibility level, and change this to .NET 4.x. And it will have the same effect, without needing to restart Unity. Let's get started by importing a sprite and getting it animating. So I'm going to bring in this sprite right into the root folder. You may wish to organize it for yourself. And if I open this up, you can see that it's a simple animated image of a penguin that has 10 frames. So in Unity Sprite Preferences, I'm going to switch the pixels per unit down to 16. I'm going to set the sprite mode down to multiple. And I'm going to go to the compression and say none, and I'm going to set the filter mode to point. And this is very important for working with pixel artwork. Then I'm going to go ahead and click Apply. Then I'm going to open up the Sprite Editor, and I'm going to go to Slice, select Grid by Cell Count. And since I know there are exactly 10 keyframes, I can set the columns to 10 and hit Slice, and then I can click on each of the individual frames to verify this looks good. And I'll go ahead and click Apply, and then I can close the Sprite Editor. So now that we've done that, we can go ahead, right-click, 2D Object, Sprite, and it's blocked by the camera, so I'll move this up out of the way here. And I'm going to go ahead and add a Sprite single component to this object. I'm going to open up its frames, because we're going to drag them directly on without any need for Mecanim. Now, if you try to click on these frames, you'll lose focus in the inspector. So I would recommend having the object selected, locking the inspector, then shift-clicking all the frames you want to use, and dragging them onto the object itself. Now we just need to set the speed, which I'm going to just guess is somewhere around 0.2, and we can immediately run the project, and you can see with as little setup as that, we've already got our character animating. Now, that works well for a single sprite, but what if you need to switch between different sprites on a character? For that, I'll refer to the sample scene that's included with Spryt Animator Pro. We have a character here who can move left and right, and jump, as well as crouch, all handled by the Spryt Animator Pro system. That's how we're getting these nice squash and stretch effects when he crouches, and even when the character dies. The same Spryt Animator Sine Effect systems are being used on these buttons and the skull itself, which is why you can see it squashing and stretching as well as moving up and down. Same with this arrow here, which is squashing and stretching and pointing at the cursor. And if there's any aspect of the demo that you want more information on, you can click these buttons down here, which are themselves animated with the system. So let's take a look at the character controller. First of all, you can see that I have the sprite itself sitting on a child of the player object, and this game object has a single frame on it, which is this preview jump frame that we're seeing here. It also has a multi-sprite component on it, as opposed to the sprite single component that we used in the previous example. Rather than assigning the frames to this instance directly, instead, it has this sprite scriptable object attached to it, which is which sprite is displayed when the project first runs. If I go up to the player itself, here we can see the actual player controller script, which has a reference to the MultiSpryt component, as well as a number of individual sprite objects. Each of these sprites is little more than a collection of frames, and in some cases it's only a single frame. In fact, the only one of these that has more than one frame is player walk. All the rest of the animation that you see is achieved through Sine Effects. So from the player standing to the player crouching, there's only 2 frames, but Sine Effects add these lovely squash and stretch, which make it look like much more. To create a sprite like this is incredibly simple. Simply right-click, select Create, Spryt Animator Pro, and then we'll select Sprite. This is going to be nothing more than a list of frames. And just like we did in our previous example, we can drag and drop frames directly onto this, although once again I would recommend locking the inspector for this. And then you can simply drag and drop any frames you want in any order that you want, and you can even use the same frame multiple times, or put the frames out of order. Let's take a look at the player script. You can see first and foremost we have a reference to the MultiSpryt component. We have multiple individual sprites, which are actually a set of frames. We have the sine data that we use to animate our instance, and we have some variables that are related to the player's movement control. We also have an audio source, which we use to play steps, and right here in onEnable, we hook into the animation end event to trigger this method every time the frames cycle through to simply play the footstep sound at the end of the walk cycle. Moving down into Update, we have a call to handle animations, which may look complicated, but this one single method does the job of an animator. You can see that it looks for if the character is in the air, and if it is, it switches the sprite index between falling or jumping, depending on whether the character is going up or down. If the character is not in the air, and is in fact on the ground, we do a check for whether the character is crouched, whether the down key is held. And here we see a use of the combo method, which allows us to assign a new sprite and a new animation profile simultaneously. The same is true for when the character crouches down in the first place. Finally, if crouch is not held, then we can assume the character is either walking or standing. So again, we assign to index either the walking or standing animation. Lastly, we modify the character's X scale depending on which direction they're moving in. You can see that being able to assign to the X scale directly is a much more concise syntax than how you would normally have to do it in Unity. Next, let's take a look at how these explanation buttons work. So first and foremost, they sit inside of a canvas. Each one of them simply has some text. They all make use of sprite single and have their speed set to 0. The frames here are not animated, and instead we switch between them depending on whether the mouse is over top of the button, has clicked it, or isn't present. All of this is handled inside of the explanation button script. You can see here that I'm hooking into simple Unity pointer events to influence which frame is being displayed, and then activating separate sine effects based on whether the pointer is entered, exited, or clicked. So when the pointer enters, I activate the Y sine effect. When the pointer exits, I trigger the rotation sine effect. And when the pointer clicks, I activate both the X and Y scale sine effects. This allows you to use a single sprite sine data to control 3 different animations playing on the same object. So you can see that sprite sine data is simply a collection of 5 separate instances of the sine class. So let's dig into how Spryt Animator Pro makes use of the sine class to drive these various effects. First, let's take a look at a traditional sine curve. You can see that as we move along a sine curve, we go from a maximum value of 1 to a minimum value of -1 and then back to 0 at a position of 2 pi, and then the sine curve repeats. By tapping into the naturally smooth transition effects that we get by utilizing a sine curve, we can produce all kinds of smooth animation effects. For example, when you mouse over a button, its position moves up and then back down, so let's take a look. The Y sign has a divisor of 10, which means the effect takes place rather rapidly, while a larger divisor will yield a longer effect. Then we have the magnitude, which influences how much the object actually moves up or down in canvas coordinates. Then we have a duration, and you can see this is set to simply 0.5. Now, duration is measured as a complete oscillation back and forth. So a duration of 0.5 makes the button travel up to its maximum value, then back down to 0. At the peak of the sine curve, we reach a maximum value of 8, which is the magnitude we supplied. Spryt Animator Pro takes care of actually shifting the game object's Y position. Then we have the scale effects, which have a much shorter duration for when the object is clicked, and what seems like a relatively small magnitude, but this is relative to a base scale of 1, so this is a 20% difference in its size. You can see that the X scale is set to positive 0.2, while the Y scale is set to negative 0.2. This way, as the X scale increases, the Y scale decreases by the same factor, so its overall volume looks preserved. Lastly, we can see that the angle sign has a magnitude of 3 and a duration of 2, which means that 2 complete oscillations will take place, moving the button back and forth. So let's see these in action. Right here with the respawn player button, you can see when the cursor mouses over, it shifts up and down, manipulating its Y position. When I move the cursor away from it, we see this oscillation, and then finally, if I actually click on the button, we get this very dramatic squash and stretch. The skull is actually using Unity's built-in Mecanim system. So you can see it has an animator as well as a reference to an actual animation, which I can display down here. And although the skull is only supposed to have 4 keyframes, we actually need to have 5 in the animation here for it to play properly. Without this last keyframe, there is not enough time allotted to the final keyframe in the animation, which is not an issue you would have if you're using exclusively Spryt Animator Pro. But you can see that through the use of Sprite Single, with no frames assigned to it, Spryt Animator Pro plays nice with Unity's built-in Mecanim, and allows for Sine Effects to be played on top of traditional Unity animations. Finally, let's take a look at the player dead prefab. This is what shows up when the player touches the skull. You can see that it has reference to a Sine Data object, and a Sine Data object simply has the data necessary for a single instance of the Sine class, as opposed to the 5 that come in a set of Sprite Sine Data. Both these individual Sine Data objects and Sprite Sine Data can be created by going to right-click, Create, Spryt Animator Pro. Here we have Sprite Sine Effect Data, and here we have regular Sine Effect Data. For more information as to what each of the fields refer to in both Sine Data, instances of the Sine class, and in Sprite Sine Data, please refer to the documentation provided with Spryt Animator Pro. So, when the player dies, it shudders, then fades out. This is accomplished by using a combination of Sprite Sine Data to make the character shudder back and forth, and then the fade out Sine Data which we supply that makes it, well, fade to 0. So let's have a look at the player dead handler script. First of all, we have a reference to the Sprite Single component, which is used on this instance. Then we have the Sine Data fade out. Then we have a private instance of the Sine class, which, in onEnable, we use the data from fadeout to create a new instance of the Sine class. Both here and here, we hook into the onEffectEnd events generated by the sprite's X sign, which is essentially when the shudder ends, this event will fire, and when the fadeout ends, this event will fire. On disable, we make sure to unsubscribe from both of these events in order to prevent potential memory leaks. The actual events themselves are relatively simple. When the X shutter Sine effect completes, we trigger the fadeout effect by using activate. When the fadeout effect completes, we destroy the game object. While the effect is updating, we create a float alpha, then call a special update method, not Unity's built-in update, on the instance of our Sine class. This will store the value in alpha, and then we assign this value to the sprite's alpha, if the effect is not completed yet. You can see that this syntax here is much more concise than what you would normally need to type to assign a new value to the alpha of an image. That concludes our extended overview on the Spryt Animator Pro system. This has been Attila Gabriel Braniecki of Bluish Green Productions.